Hear me now?
Yes, yes, now, yes, yes,
Okay.
now audio is
Okay.
clear.
Okay. Good afternoon, everybody. Good afternoon, all the faculty members who joined us for today's seminar. Good afternoon, Vidula madam, and thank you so much for accepting our invitation at such a short notice for guiding our faculty members on. Today morning we had one session of virtual. Today morning we had one session of virtual lab, and this is the second session today evening for virtual labs. And I believe that you would be guiding the teachers on how to work with electronic circuits, or how do we create electronic circuits online. It could be Tinker, it could be any other software that you have planned. Good afternoon to all the teachers who have joined us. National College has, received the permission to conduct virtual labs as late as September 2020. We were in midst of a lot of examinations that we had as per the university calendar. So we thought that this was a good time to initiate the process of having the virtual lab. So over to Milind sir to introduce and start the session, please.
Thank you, Dinesh sir. Professor Vidula Kulkarni is currently with Oriental Engineering College, okay, and Masters in Electronics and Communication Engineering, and she will guide how to simulate different types of digital logic gates, electronic circuits, which makes using that we can make a logical decision. Okay, uh, welcome Vidula ma'am, and you can
Yes,
proceed,
ma'am.
ma'am.
Yes. Thank you, sir. See, everyone, during this pandemic, virtual lab play an important role in teaching and learning process. The base of every technology is digital electronics, and we are here to learn the virtual lab for digital electronics. I am also a learner in this field, similar to you. So please feel free and discuss any issue. So I will start sharing my screen with you. Hope my screen is in front of you. If any problem in between arise, you can just discuss with me. So this is one of the software. Before starting that, let me start beginning. So yeah, we all are gathered here for the Digital Electronics Virtual Lab. I am head of the IT department from Oriental Education Society. Digital electronics, as we know, it is the basic for everything. As we know that B starts from 0 and 1, and we all are teachers. Daily, we are dealing with zeros and ones only. So today, we will go through two softwares that are Logisim and Tinkercad. Virtually, we can operate it, and these two softwares features are a little bit different, but we will enjoy these two features. So we all are aware about the logic gates, different types of logic gates, where the basic gates are AND, NOT, and NOR, universal gates, NAND, NOR, and the special gates like XOR and XNOR. So AND gate, the Boolean expression Y is equal to A dot B. So now what I will do, we will prepare the circuit for it, we will simulate it, and we will check the result virtually. Okay. So this is the software which is freely available, open source software. It is Logisim. Logisim, freely available. We can download it. Here you can see different toolbars are there, like file, edit, project, simulate, window, and help. See, if the screen is not visible because the alphabets are little bit small, you can zoom at your end. Okay. So in the file, we can go for new, open, then the recently opened documents we can open, close, like other softwares. These are the tools and which are quite user friendly. Even in editor section, we can see, say, copy, paste, cut, edit, that type of options. Even in the project, we can add circuits, load the library, unload the libraries, and we can see the simulation. We can simulate the result. That tool is available. Then Windows to minimize and maximize, even we can close. In the help, the detail about this software is provided. So you can say here, the user guide, it will help you See, I'm opening the user guide. Inside that, the detail about Logisim software is available. That means beginner tutorials are provided. Initially, as a beginner, step number 1 is you should know the truth table and the circuits related to that. After, say, going for that, the step number 2 is adding the gates into the Logisim. We will see all these steps one by one today itself. Then step number 2 is adding wires to that gates. After that, we can add text to that particular diagram, and we can test the circuit. That means we can simulate the circuit whether it is running properly or not. And yeah, user guide, time to time we can take help from the user guide. Okay, now here, whatever tool section we have seen, the shortcuts are available for us. Here, if you press, or you can check that change a value within the circuit to connect the wires. It is the edit section where wires can be connected. Then look at the cursor. That A section, it is nothing but you can edit the text. That means you can write the data, and small tools are available. We will see one by one. Okay. Here, folders are created. If you click on the plus button, in wiring section, there are the filter, pin, probe, tunnel, pull resistor, clock, power, ground, transistor. So many tools are available. Now in the gates, as we are dealing with the digital electronics, we all are aware about the basic gates, special gates and all, and that gate symbols are available with us. So NOT gate, buffer, AND gate, OR gate, and like that. So now I will show you the simple demo of AND gate. But before that, we will go down and see what are the other folders available. Next is flexors. In that, you can see multiplexer, demultiplexer, decoder, priority encoder, bit selector are available. Other tools are like adder, subtractor, multiplier, divider, comparator, shifter, bit adder, and bit finder. Even memory related section is also available, like say our flip-flops part where D, T, JK, SR, counter, register, shift registers, these type of sections are also available. We can simulate it with the help of Logisim. Even we can see at the input section where button, joystick, LEDs, keyboard, these are the different components which are available for us. And even these are the base where we can see the exact simulation of the components or the gate. So initially, we will go for the simple practical of say AND gate. So I have selected AND gate. One tool section is opening. The specification of AND gate is provided here. What is that? It is facing towards the east and data bits are 1. So we can go for 2, and even we can say data bits where keep it 1, and here the input data, say 2 input gates we want, and size wide, and from here I am increasing the size also of the working area, and now you can see the AND gate is placed. Okay, it is a 2 input AND gate. So just drag and drop option is there. I'm using the switch. Just click on that icon and drag it onto the working area. Once again, go at the switch because we are in need of the second input. So just drag and drop. Initially it's at reset condition 0. We want to check the output. So for that, the structure which is already provided here to check the output, that I am dragging on the working area. Now arrowhead in the tool section. So just click on it and connect the wires. Okay. Likewise, the second input. So simple AND gate, two inputs are given. Now we have to check the output side. So connect the connecting wires. Everything is connected. Now we have to give name to this circuit. So it's a AND gate. So simple AND gate we have written. Now we have to check output here. The hand-like structure, it is poke. So you just click on it. And suppose my one input is 1, another one is 0. It is like a multiplier. So output is 0. But when my both the inputs are 1, my output is 1. That means we can check the observation table that when my both inputs are 1, naturally my output is 1. So likewise, it is just the simple example of AND gate. We can go for OR gate, NAND gate, XOR, XNOR, and different circuits are possible with the help of this Logisim software. Now, I will show you. Just come back to my original slide. Yeah, just now we have seen how to implement the AND gate on the Logisim. The observation table, that is the simple output, that means the combination of input and output, and what is the output related to that we have observed. So the IC required for it is 7408. We all are aware for that. This is the structure for 7408. Here we can see that 1 and 2 are the input and 3 is the output. 4 and 5 act as input, 6 output, 7 always ground, 14 goes to VCC, positive of the power supply. Here 8 is the output for the third AND gate, and 9 and 10 act as an input for the third NAND gate. For the fourth, 11 is the output and 12 and 13 are the input. This is the symbol structure. Now I am showing you one more software. With the help of that, we can draw the circuit like AND gate. Okay. So my screen is visible. Hope I am audible. Everything is okay. Milind sir, am I audible?
Yes, ma'am. Audio is clear.
Okay. So in the Google, I am searching Tinkercad. So Tinkercad asks you whether to join or join the particular class, or you want to connect directly with the Google. Okay. So now it's coming. Okay. So if you click on Tinkercad, the dashboard will open. Basically, this is the tinkercad.com website. And on this, there are the options like say join your class or start tinkering. Initially, we will start with start tinkering. Then here are the options. So just click on sign in. Yeah, you can sign in with Google. Okay, it is coming. Okay, so we can join with the help of Google. Okay, so look at this screen. The dashboard of Autodesk Tinkercad is open. Okay. Here on one side, 3D design option, then circuit, then code block, that options are there. We have to go for the circuits. Okay. So before starting this, I'm showing you the circuits which I have already created. So you can see on the screen, this is the simple circuit of 7408. Now I want to tinker this. Okay. So this is the simple circuit which Tinkercad is providing, and more features are available. That means we can select the LED, we can select the resistors, as all digital electronics related practicals are based on the components only, like ICs, resistors, LEDs, connecting wires, breadboards. So simulations with say pictorial form is a little bit interesting for the students also. So here you can see the ICs, that is 7408. It is a 14-pin IC. Here pin number 7 is grounded. Pin number 1 and 2 goes at VCC, because we are checking the last condition only, that when both the inputs are 1, output is 1. Then pin number 3, where resistor is connected to the LED and cathode terminal is grounded. Power supply is provided to the positive and negative. And now we will see the simulation. What is the condition? Both the inputs, say input A is 1 and input B is also 1. Then only our LED will be on. So here is the option which is provided in the Tinkercad, start simulation. So if you press on start simulation, the LED starts glowing. Again, if I say stop simulation, LED stops. Once again, the color of the LED changing, that means it is glowing. So in this way, with the help of this Tinkercad software, we can design the circuit, we can use this digital electronics virtually. Okay, so I will show you how to do all these practicals with the help of Tinkercad. Okay, so here at the circuit, first we have to select create new circuit. Here different options are available. Okay, we have to select all. That means all components are available for us. At the search, we have to type breadboard, because initially we have to start with breadboard only. 3 types of breadboards are available. Just click on the breadboard and drag it. So breadboard is available, only one breadboard we required. And the structure of breadboard is also predefined. Here you can see the negative, ground, positive, plus VCC. Once again, negative, ground, positive. Here the columns, say from column number 1 to up to column number 30. And rows are also available, say from A, B, C, D, E to up to F, G, H, I and G. So we all are aware about the breadboard structure. That means vertically these columns are separate, right? And negative and positive, that horizontally short. Okay. So now the simple practical which we are going to perform, that is the IC say 7408 only. But before that, I'm typing 7408. Yeah, the IC is available. I'm dragging that. Insertion should be proper. Okay. Yeah. Now it's placed. Okay. Now The next is ground and VCC. So for that, we required battery. So type battery. If you type battery, options are available for us. That is 9-volt battery. No, we required around 5-volt supply. And here we can see that only 1.5 volt, simple other batteries are available. So I'm selecting 1.5 volt. But according to rule, we want around 5 volt. So if you click on it, here is the option for 1.4 volt battery. Count 1, that is around 1.5 volt. So what we will do, we will select 3 batteries. That means what? It is around say 4.5. Yeah, that's okay for us. So we have selected it. We want to rotate. We can rotate that particular part with the help of this button. Say rotate. Now the battery is rotated. Okay. Second is, on that battery, if your cursor goes near to that particular option, you can see negative and positive of that particular battery. So same for that breadboard, we have to connect the negative on one side and positive also to the down. So this is our traditional method to give the positive and negative supplies to the breadboard basically. Now we want to connect pin number 7 to the ground. So what technique we are using? From this, I am connecting the wire to the negative part. Okay. Yeah, even you can change the color of these wires also. If you click on the wire, on one side, the options are there. What are that options? Different colors. Particularly for ground, we are using black color. So I am selecting black. Now say for positive. For positive, which color we are using basically? Red color. So I am using red color for that. Here the ground section, that means both are shorted and that is grounded. Okay. So now the same IC I will show you. Yeah, this is the same IC where input 1, input 2 and at pin number 3 we have to check the output. Okay. So pin number 7, this we have to give it at the ground. We have to insert it at the ground. So I'm changing the color for it, black. Right. Then pin number 14, we all know pin number 14 goes to VCC. So from pin number 14, we are connecting it to the positive supply. And the color we can give blue. Okay. So positive is given, negative is given. Now what is the next step? We have to connect the inputs. So we are checking the condition when both the inputs are 1, 1. So I'm taking one wire from this side and inserting that wire into positive supply. This is my input A. Now input B. For input B, once again I'm connecting it to the positive of the supply. Connections are over. Now we have to connect the output also, that means LED part. So to check the output, we have to connect LED. So here, search for LED. Different options are available for the LEDs. Just click on the LED. Again, drag and drop like this. I'm inserting. Okay. So this is anode and this one is cathode. So cathode I am directly providing to the ground. Done. Now for the anode, we cannot connect it directly. So we want resistor in between that. And output we have to take from pin number 3. So I'm searching for the resistor I got the resistor, but the resistor is vertically short. Now we want to rotate it. So with the help of rotate, just rotate it properly. Okay. And the other end of the resistor goes into the pin number 3. Okay. So what we can see, that pin number 3 through resistor connected to the terminal 1 anode of the LED, and negative terminal goes to the ground. The connections are over. Now still, as we are using both the sides, we have to connect the connecting wires so that both the sides are connected. Here also. Okay, so now our circuit is ready. So cross your finger. Let's check whether it will run or not. Yeah. So you can see that when both the inputs are connected to 1 and everything, the connections and everything is okay now. And at the simulation, we can see, we can observe the output that LED is glowing. Okay, this is just simple example. Initially, we have started with this, but lots of circuits, that means with the help of say Arduino, Raspberry Pi. Raspberry Pi is not available in the Tinkercad, they are working on it. But yeah, for Arduino, definitely different hardware circuits, different combinations for Arduino is also available into it. Now we will go in depth what is that. So this is the circuit which we have seen. Even different components which are available that we will see now. What are that components? In general, resistor, capacitor, Zener diode, even input devices like push button, potentiometer, then slide switches, photoresistor, photodiode, then ultrasonic distance sensors, PIR sensors are available. Output devices like LED, bulb, that options are available in Tinkercad. Even DC motor with encoder that are also available. 7-segment display is provided to us. Power supplies as per requirement. Breadboard, different size breadboards, mini, small, like that. Even microcontrollers. Yeah, function generator is also available. Oscilloscope is also available. So really, it's advantage for all the electronics engineer as well as physics people that yeah, everything is with us. Even timer IC 555, op-amp, that are also available. So I will give you a short introduction about it, that are connectors, then the logic circuits like say 7400 NAND gate, NOR gate, AND gate, then Smith trigger, that circuits are available. 7-segment decoder. Now back to work, back to my previous slide. Yeah, OR gate, we all know about the OR gate, like the same, y is equal to a plus b. Then the Boolean expression, it is like a adder, the same type of circuit. This type of circuit also we can form with the help of Tinkercad as well as Logisim. Okay, even NOT gate 7404 IC is available for that. So we can see the inverter also. Universal gates like 7400 NAND gate. The implementation of NAND gate is also possible. Even with the help of Logisim, like when AND gate and NOT gate we can connect and we can observe the output. And now in the Logisim itself, I will show you one more demo of multiplexer. So this is Logisim, which is quite user friendly. We can go for it. So now let's see how to create a multiplexer and how to check the output of it. Okay, so a new start, a new beginning for us. At the plexer, you can see the first option, multiplexer. If we click on it, naturally the toolbar is coming out and facing and every options is given to us. Select bits are nothing but the select lines. So we are selecting the select line, say 2. Okay, and data bit is 1. And just drag and drop option available with us. So I have drag, it's a 4 as to 1 multiplexer. We all are aware it's many as to 1. Now we have to check. We have to connect the input and we have to check whether only a single output is going at the output side or not. So for that, we are using this switch. Now I'm inserting the switch and we can see that the facing of that switch is towards east. So from the selection pin session, we can change the facing, say towards south. Okay. So why? Because we are making these diagrams quite user friendly for us, for everyone. That's why. So once again, I am selecting 4 inputs are required. So I am selecting the second switch, again going down and say facing down. Again the third switch, say I'm inserting that, pressing it down, just, and the last one, last input I'm taking and just pressing it towards south. Likewise, 4 inputs are there. Now we have to connect that input to the mux. So I am selecting first input and connecting it to the first. So this is my I0, I1, I2, I3. 4 inputs. Now second, like this. Third input we are connecting. This is I2 and the last input which is I3. Done. We have connected 4 inputs. Now here is the select line option. This select lines we have to take out. Again one switch we have to connect to it. And yeah, now you can see that as soon as I connect it, at the bottom side there is the option incompatible with. That means what? Some error is there. And what is that error, you know? Here we have given a single input, but select lines are 2 only, S0 and S1. We all are aware. So here the option we have to change and say 2. Okay, that means now the select lines are 0, 0. We have to see the output. So at the output side, just connect the session and connect the wire to it. Okay. Now, still something is pending. That means we have not enabled this IC yet. So we have to use enable pin. And change the direction of this pin. Okay. Now, suppose, now we want to simulate it. I am giving 1 over here. Now, what will happen? That we will change because our enable pin is 0. So nothing is there at the output. This pin should be active high. As I am making this pin active high, you can see that I0, at I0 as we have given 1, the same one is appeared at the output, and it is active high signal for this Logisim simulator. Now suppose I am giving 1 at this, and this is my pin number, say this is 0001, and this one is 10. So I'm making this 1. So 1 over here. Now suppose if I am giving both inputs are 1, naturally when both inputs are 1, then it's I3 bit, and I3 bit value is 0, and the same 0 value is displayed at the output. So in this way, we can explain the student about 4:1, 8:1, 16:1, and student will is working. Now back to our original slide. So NOR gate, we all know we can drag and drop the circuit for OR gate, and output of OR gate is acting as the input of the NOT gate. And in this way, we can create NOR gate. The IC of NOR gate is little bit different than the other ICs, the direction wise. Even we can implement De Morgan's law for the students. Then implementation of basic gates using the universal gates. That circuit also we can implement on Logisim. Not only that, the same implementation of NOR gate, basic gates with the help of NOR gate. Then 2 input XOR gate, 7486 IC. We can check the input conditions. We can form the circuit using Logisim as well as Tinkercad. Then the circuits using NAND gates, NOR gates. Now, these are the circuits, these are the ICs. We all are aware about the IC numbers, their configurations and all. As we have seen up till now that, yeah, Logisim and Tinkercad are the 2 tools with us. With the help of that, we can simulate the electronic devices. So I'm showing you one practical which we have performed. That is the basic gates related practicals. Now I think it's very easy for everyone to simulate it. So for AND, OR and NOT basic gates, this is the circuit for it. Now universal gates also, NAND gate and NOR gate, and observation checking, that means the truth table verification with the help of tools which are available in the Logisim. Any type of circuit, any type of Boolean expression we can simplify and we can check the output with the help of Logisim. De Morgan's law, then circuit implementation, basic circuit implementation using universal gate NAND, basic circuit implementation using NOR, then XOR gate using basic gates, XOR gates using NAND gate, NOR gate, the circuit simulation. Yeah, this is one of the circuit which I am showing you. XOR gate and AND gate. Yeah, we all are aware it is a half adder. Half adder circuit implementation, we can see it now. Okay, so new, right? So at the gate section, what we have to do? We have to select XOR. So for XOR, number of inputs required basically 2. So XOR we have taken. Now 2 inputs, switches are required for that. 2 inputs. Adder I am creating for you. Then connecting wires we have to connect. Sorry. Okay, fine. So we have provided input. So what is the output of it? Output is A XOR with B. So we have connected the output session with the help of connecting wires. Okay. So when alternate inputs are there, then only output is 1, else it is 0. Now, here is the circuit. Adder output is sum and carry. So carry is nothing but A dot B. Here, carry. AND gate is required. I am using AND gate. We have to change the AND gate inputs. So I am using AND gate input 2. So from this, one input is connected to the AND gate. Second input is also connected. Second input is connected to the AND gate. And final output we have to check. Fine. Now, XOR and AND. This is the complete circuit of half adder. So, to simulate it, suppose this input is 1. 1 XOR with 0, some output is 1, but at that time, 1 and 0, it's like a multiplier. So the carry is 0. When both the inputs are 1, 1, then when both the inputs are 1, then at that time, sum is equal to 0 and carry is equal to 1. It is the only one condition when carry is equal to 1 in case of half adder. Okay. So if we want to create full adder, then we can copy this circuit. And we can paste the complete entire circuit. Copy, paste. So the whole circuit can be copy and paste. Drag and drop, copy and paste. That is also one of the options. Now coming back to my original slide. So like this, we can go for half adder, even half subtractor. As one NOT gate is inserted, the circuit is converted into half subtractor and the output is difference and borrow. That type of circuit is also formed with the help of logic. Even full subtractor. Then multiplexer, 2:1 multiplexer. Then trees we can form. And this is the circuit which we have just now completed, that is sum and carry, where 0, 1, 1 is the sum and carry column is 0, 0, 1. Same for the borrow. So adder circuit we have created, where with the help of Tinkercad also, we can draw the circuit like this, where XOR 7, 4, 8, 6 we can drag, and 1 and 2 and 3 output. Same, 1 and 2 input and 3 output. So for half adder also we can go for Tinkercad. Full adder, same circuit can be implemented with the help of Tinkercad. Half subtractor, we can go for that. So these are the circuits. Even with the help of gates also, we can form the multiplexer. So this is 2:1 multiplexer. Just now we have seen 4:1 multiplexer, and this is the simple one for 2:1 multiplexer. 4:1 multiplexer, as we have completed now, the concept over here, that I0, I1, I2, I3, 4 inputs we have given, and the select lines 0, 0, 0, 1, 1, 0, 1, 1. And these are the control lines. And as per the combinations, the particular output is displayed. So same is the circuit for mux. Even this is also one of the mux, where only gates are used, not gate, AND gate, OR gate, like that. So we can implement it as to 1. Yeah, even we can go for the comparator also. The comparator circuit with the help of gates. So here 2-bit comparators, 4-bit comparators are available in Logisim. So yeah, flip-flops are also available. So we can design different flip-flops with the help of Logisim as well as Tinkercad. Now I will show you the projects. Yeah, this is one of the interesting part. Here, the function generator and oscilloscope combination. We can generate square wave, sine wave with the help of these simulating tool. So as the simulation start, so we can change the waveform. Initially it is a square waveform. So sine, the waveform is changing, square, triangular. So as per the requirement, we can change the waveform. We can use the oscilloscope and function generator. That is also one of the facility provided by Tinkercad. So different circuits are also available. So here I am concluding my session that yeah, really that virtual labs are playing very important role to improve a teaching learning process, and it is the base of every technology. And yeah, it is hope this session is helpful for you, and thank you everyone, and over to you, sir.
Yes, thank you so much, ma'am, Vidula ma'am. Yes, if you have any query, any suggestion, yes, dear participant, if you have any
Yes.
suggestion, query, please you can ask. Now session is open for question and answer session.
Sir, I'm Narayan, sir.
Yes, sir.
Hello.
Sir. Your audio is clear, sir.
Okay, sir. I want to ask one doubt
Yes, sir.
because I've not seen that when I'm selecting various components from that box. So when you're selecting diodes, the automatic various types of diodes appears over there.
Yeah.
But when you selected the register, there is no option for how to select various valued registers. So is it there?
Yeah. It is there, sir. It is there. I'm showing you that also.
Okay. Then
Yeah,
no doubt. But since other options are automatically comes over there, resistance only picture had come and
No. Actually, sir, for resistor also, if you click on that component, then the features or specification will come, that whether you want 1K, whether you want 500 hertz, or even for frequency also it is there.
Okay. Doubt is clear. Okay, thank you, madam.
Sir, by selecting resistor, there is one icon. In that icon, you can select your exact desired frequency. Is it correct, Vidula ma'am?
Yes, sir.
Yeah.
I got it. My doubt is solved because madam told you when you select the icon of resistance, there is another window that which appears.
Yeah.
I think I missed, and therefore the doubt arose in my mind.
In that you can you can type your required value of resistance with unit ohm, kilo ohm, like mega, like that.
Okay, thank you, sir.
Yes,
there's one more doubt in the chat box. There is one doubt.
Yeah.
Bola ma'am.
Aarti Nair has a doubt.
Okay, Aarti ma'am, please proceed.
Yeah, I just wanted to know, you have these 741s. See, basically we teach the 12ths. So they
Yeah,
have
correct.
one set of experiments which are all the digital electronics, everything that ma'am so beautifully said. But in paper 1, there are lots of 741. That means your op-amp.
OPAMP.
So
Yeah, that is
that
also
is
available,
also,
ma'am.
that is also available in this, ma'am?
Yes, yes,
Oh,
yes.
perfect. Thank you so much.
Yes, any query? I think there is no. Yes. Namrata ma'am, can we proceed for vote of thanks?
Yes.
Yeah. Sima ma'am.
Yes. Thank you so much, Vidula ma'am. It's my immense pleasure to give you thanks for such a nice presentation and a session on the very basic conducting the online experimental sessions, virtual labs for the basic experiments, including consisting of the gates and the advanced experiments like waveform generations and the, as ma'am said, the op-amps and all. Thank you so much, ma'am. It's really a great advantage to all the teachers to have the current practical examination and also in the upcoming terms. Thank you so much, ma'am. Thank you.
Thank you, Sima ma'am.
Thank you all.
Yes, Namrata ma'am. Yes. Yes. Thank you, Vidula ma'am. Thank you so
sir.
much.
Thank you. Thank you.
तुम्ही
Thank
अजून
you
काय
so
काय प्रोजेक्ट
much.
करताय मॅम? विदुला मॅम?
Yes, sir.